On behalf of the National Child Passenger Safety Board, thank you for joining us for this NCPSB webinar, Tech Guide 2.0, a deeper dive into the why, an hour-and-a-half supersized National Child Passenger Safety Week special. I am Justin Young, the Public Safety and Law Enforcement Representative of the National Child Passenger Safety Board and Certification Recertification Committee Co-Chair. I'll be moderating the webinar today, and I tell you, I'm really excited for the information that we're going to be receiving. We have planned some time to answer questions at the end of the presentation, so please enter your questions into the Q&A box as we go along. It helps us to keep them separate and keep better track of them. As a reminder, attendees are requested to not participate in this webinar if you are operating a motor vehicle. Webinar will be recorded, and you can listen to the recording when you safely arrive at your destination. Recording will be posted to cpsboard.org/recertification within 1 to 2 business days. For the child passenger safety technicians in attendance, the presentation qualifies for 1.5 CEUs. In order to earn the CEUs, attendance on this webinar is required for at least 75 minutes. Proof of attendance will be emailed 24 hours after the webinar. On to our presenters. Jennifer Pelkey is a Senior Engineering Manager in Advanced Interior Safety and the Child Passenger Safety Subject Matter Expert at Toyota's R&D facility in Saline, Michigan. Jennifer earned a Bachelor of Science degree in Mechanical Engineering from the University of Michigan, but since she was raised by 2 Michigan State University Spartans, she didn't really mean it. She joined Toyota in 2008 as an evaluation engineer in vehicle safety. Her passion for child passenger safety came with motherhood, and she became a certified child passenger safety technician in 2012 after struggling to find a car seat to fit her vehicle, which was definitely not a 2-door sports car, because that would be ridiculous. Additionally, Jennifer is the chairperson of the National Child Passenger Safety Board and a member of MACPS. In her nearly non-existent free time, she is an aspiring aerialist, but somehow has not yet received a recruiting call from Cirque du Soleil. She has also recently started learning to play ice hockey as a backup plan in case this whole engineering thing doesn't work out. Daniella Brown with UPPAbaby. Having worked in the juvenile products industry since 2007, specifically in the car seat industry, Daniella brings her seasoned experience of the manufacturing and development process to the board as the child seat manufacturer representative. Prior to working in the juvenile industry, Daniella was a vehicle seat engineer for more than 8 years at Lear Corporation, working on projects for Ford and Mazda. She has an in-depth understanding of a vehicle's dynamics in a crash condition and how the body reacts to crash situations. Our presenters will take you inside the industry to give you a better understanding of the driving forces behind many recommendations and ideas for explaining these concepts to caregivers.
All right, thanks, Justin. I'm going to take the screen here. And hopefully that has switched over. Thank you, Danielle, for letting me know. All right, great. Well, thanks everyone for joining us today. Again, I'm Jennifer Pelkey with Toyota, joined by Daniella Brown, and we are 2 engineers who are going to try not to nerd out on you too hard today, but teach you some of the reasons why we have the best practice recommendations that we do. So I'm going to kick it off for you today, talking a little bit about airbags. So in your technician guide for your CPSC certification, you learned about the different types of airbags in a vehicle and how to locate them. But you might still be wondering, why is it considered safe to install a child restraint next to a side curtain or seat-mounted side airbag when we definitely don't put those in front of frontal airbags, especially for rear-facing? And what should we know to tell parents regarding side impact airbags? So before we jump into airbags themselves, I want to take a little bit of a step back and start with a review of crash dynamics. This is just a short video from the Insurance Institute of Highway Safety. that talks about inertia. And I think it's a really good starter to this conversation.
Why'd this dummy get left behind? It's called inertia, the property of matter that causes it to resist any change in its state of motion. Galileo introduced the concept in the late 1500s, and almost 100 years later, Newton used this idea to formulate his first law of motion, the law of inertia. It's why the dummy fell off the back of the truck. It was at rest, and it wanted to remain at rest. That's inertia. It's the same property that keeps the china on the table as you pull the tablecloth out from under it. Now what about a body in motion? Am I a body in motion? You bet I am. I'm moving 35 miles per hour. But from one perspective, it may not look like I'm moving at all, because in relationship to the passenger compartment, my position isn't changing. But if you look at me from the outside, you can see that I'm moving at the same speed as the vehicle, in this case about 35 miles per hour. And if Newton was right, and we know he was, I'm going to keep on moving at the same speed until an external force acts on me. Now, what does this mean to occupants of a moving vehicle? Watch this. See how the car and the crash test dummy are traveling at the same speed? Now watch what happens when the car crashes into the barrier. The front end of the car is crushing and absorbing energy, which slows down the rest of the car. But the dummy inside keeps on moving at its original speed until it strikes the steering wheel and windshield. This is because the dummy is a body in motion traveling at 35 miles per hour and remains traveling 35 miles per hour in the same direction until acted upon by an outside force. In this case, it's the impact of the steering wheel and windshield that applies the force that overcomes the dummy's inertia. Inertia is one reason that seatbelts are so important. Inertia is one reason that you want to be tied to the vehicle during a crash. If you're wearing your seatbelt, you slow down with the occupant compartment as the vehicle's front end does its job of crumpling and absorbing crash forces.
All right, so let's consider how we might experience this in our daily lives, right? So when a vehicle is involved in a crash, it may come to a sudden stop very quickly. And we just heard we can reduce the chance of injury to the occupants by using the vehicle to extend the time it takes the occupants to come to a stop. So this is known as the ride down effect. So you might not realize it, but you do know this instinctively from other experiences. So if you're just standing, even just in the middle of the room, and you jump up in the air, even just a small distance, and come back down, what do your knees do? Well, if you think about it, and if you've tried to do this, and if we were in person, I would demonstrate it for you now. Even if I were to jump just a couple of inches into the air, it would be really hard for me to land with my knees bent. My brain would just not want to let me do that. Why? Well, it wants my knees to act as kind of that crumple zone in the car. It wants my knees to extend the time it takes my body to stop. When I jump up and land with my knees locked, then it comes to a stop very quickly. And if you guys have tried it, you know, it actually hurts. It's not something that you want to do. So what are some other ways we see this in our lives? Well, have you ever gone bungee jumping? Maybe not, but have you at least seen it? So there's a reason it's bungee jumping and we don't use something, you know, non-stretchable like a rope. And I think about this every Christmas when I watch Die Hard, because it is a Christmas movie, and don't argue with me about it. It's not a point we're going to argue. So the scene where Bruce Willis, he's on the top of the building and he's got a fire hose tied to his waist because the bomb's going to go off and explode the top of the building. And he jumps off. It makes me cringe every time, because as that very stiff rope, right, would stretch all the way out and he'd come to that kind of really abrupt stop at the end, it wouldn't be the swing through the glass of the building that would be the big problem. It would be that kind of long drop and that sudden stop that would be a bigger cause for concern. Same thing if I were to toss one of you, say, a raw egg through this screen, right? How would you catch that egg? Would your hand be very stiff and would you catch it very abruptly? No, you would cradle it as it came towards you and kind of slow it down over time. So it's the same principle that we're using in the vehicle. So again, just that jumping, landing with your knees bent, extend the time it takes for your body to come to a stop. So how can we extend the time it takes for an occupant to stop in a crash? We can extend the time it takes for the vehicle to stop. So crumple zones in a vehicle absorb energy and help slow the vehicle down more gradually than if it just was a stiff, rigid structure.
With the crumple zones in the car. So in the front and the rear are basically designed
not
to
sure.
starts with the crumple zones and starts with the crumple zones
make
in the
that
car.
stop.
So in the front and the rear
So
are basically
the
designed
seatbelts
to
help
starts
tie the
with the
occupant
crumple
to the
zones in
vehicle.
the car. So in the front and the
This
rear
is
are
too
basically
used to have
designed
audio,
to
but
starts
yeah.
with the crumple zones in the car. So in
So
the front and the rear
seatbelts help
are
slow the
basically
occupant down
designed to
with the
starts
vehicle
with
to take
the
advantage
crumple
of
zones in the car. So in the
the
front and the
airbags
rear are
additional
basically
occupant
designed to
experiences
starts
that
with
the
the
crash
crumple
forces
zones in the
over the
car.
larger area of the body. Okay, I think I got that. All right, so when we look at these pictures here from the video that we watched, we can see how much the front of the vehicle is crashing in the first two images, or crushing. So we have all of this space that becomes this very small space here. And then we look at the occupant. So when the occupant is not tied to the vehicle, we can see how far he just slides forward. So as he moves over that distance, he's not taking advantage of this energy absorption in the front. But when he's tied to the vehicle, the amount that he just simply slides forward is much less. So once he's tied to the vehicle with the seatbelt and also with this airbag, then he's able to take much better advantage of the crumple zone in the front of the car. So when we think about the physics of a crash, it really does happen literally in the blink of an eye. So quick exercise, I can't see you, but humor me anyway. If everyone blink your eyes, how long does that blink last? Well, the blink of an eye lasts about a third of a second, so 0.33 seconds, which is about the same as a typical vehicle crash. That's about 300 milliseconds or less, so about 0.3 seconds. So the crash is often over before the occupants even realize a crash has happened. So vehicle computers must process data, and airbags have to inflate even faster than this to help restrain the occupant. So this video is from Volkswagen, and it's a commercial from several years ago, but I kind of like how it shows kind of how quickly and out of nowhere a crash can happen.
It gives me the feeling like she's not like listening to me.
Have you tried not saying like every other word?
What?
Remember your ski trip story?
Yeah.
I was like going down the hill and like this guy like cut me off and like there was a crowd and like
come on, that's
and I was
not
like,
me.
look, stuff either happens or it doesn't happen. Stuff doesn't sort of like happen. Holy.
And so an actual airbag in a crash would inflate even faster than it shows in that video. That's still sort of a Hollywood recreation. But I still like kind of how it shows that this crash can just be very unexpected. So let's talk about airbags and types of cushions in the vehicles. So we have, of course, our frontal airbags. So these are large, powerful bags in the front of the vehicle. They actually have to be strong enough to stop an unbelted occupant. That's why we never want to put a rear-facing child seat in front of a frontal airbag. Next, we have a knee airbag. So a knee airbag is used to help reduce loads into the knee and thigh, but it's actually also used to help tie the occupant to the vehicle as well. So you can think as the occupant would slide forward, their knees would contact this airbag and it would help prevent them from sliding forward. Seat side airbags are mounted to, as you guessed it, the side of the seats, and they help reduce loading into the pelvis and torso. Then we have curtain airbags, which are the large bags that inflate from the roofline. They provide head protection and side impact and rollover accidents, and they actually have a minimum amount of time that they have to remain inflated. As you can imagine, a rollover crash would last much longer than a typical front or side or rear crash. So what are the main differences between front airbags and side airbags? Well, if we watch this video from a frontal crash, you can see how this driver airbag, when it deploys very quickly and directly towards the occupant, spreading those crash forces out over the larger area of the body. And now when this side crash happens, you can see that seat side airbag and the curtain airbag deploy very differently. They deploy in that very small space next to the occupant, protecting the occupant's torso and head from the vehicle interior and that incoming pull. So they're very good at sneaking in that very small space. And while they're still spreading crash forces out over a larger area of the body, just like the frontal airbags, they do it in a different way. So what does this mean when it comes to child restraints? So again, those front airbags are larger, more powerful, deployed toward the occupant. So a child restraint positioned in front of that airbag, the child restraint would raise that child up and move them forward, so actually closer to that powerful airbag deployment. However, those side airbags, as we saw, are narrower, less powerful, and they deploy between the door and glass and the occupant to absorb energy and protect the occupant from the window, the other interior striking object. So a child restraint positions, again, the occupant higher and more forward, so not towards the deployment. And that boosted height of the child may actually allow for better head protection from the curtain airbag, as they could get better interaction with it. So out of position testing. So this is one way that we know about any potential risk from side airbags. So out of position testing is part of NHTSA's new car assessment program, or NCAP. And it provides customers with more information about vehicle side airbags. It is voluntary, so auto manufacturers don't have to conduct this testing, but it uses unrestrained 3-year-old, 6-year-old, and the small 5th percentile female dummy. And it's essentially a worst case test condition where the occupant is directly in the path of a side airbag. So if you think about a child properly restrained in a car seat, they would be in a much more protected position than any of the dummies in this out of position testing. So what does it look like? So this is an example test. This is the small female. You can't quite tell, but her head is actually leaning directly on the glass. So if we watch the airbag deployment here, we can see that although it contacts her head, it's still very good at sneaking in the space between her head and the window. So it gets down in there and it does push her outboard, but again, it's getting in that space, not really posing a risk to her. And in a crash, then that airbag would then be able to prevent her from, the window or contacting the incoming vehicle. So how can you find out if your vehicle meets the OOP requirements? Well, you can go to nhtsa.gov/ratings. It's a little bit hard to find. So you would enter the year, make, and model of your vehicle, and then scroll to the bottom of this yellow section. And you'll see this all vehicle safety features. You can click on the little triangle here, and then you will get some additional information. So under the airbag section here, you would see whether or not it meets the side airbag out of position requirements. So what's the takeaway from all this? What should we actually tell parents? So the key points here are that side airbags are different from frontal airbags, and that they deploy next to the occupant rather than directly toward the occupant. That means that children who are properly restrained in forward-facing child restraints or booster seats may actually benefit from their increased head protection from the curtain airbags due to that boosted height. So we want to still keep children out of the direct deployment path of the airbags. We want to prevent them from leaning their heads or bodies against the door or window. So this photo here is actually of my little guy a couple of years ago, and he was still complaining about being in a 5-point harness, which, sorry, buddy, my job is to keep you safe. But you can see as he's falling asleep here, because he has those side wings, it's keeping his head away from the interior and away from the window. So if children are still at the age where they fall asleep in the vehicle, keeping them in that 5-point harness or a high back booster may help them stay in position even if they fall asleep. So one more quick video just as a bonus here. Let's talk for a minute about the evolution of vehicle safety. So it has evolved dramatically over the past 60 and more years. Modern vehicle structures, seatbelts, and airbags give a much higher level of protection than in older vehicles. Let's take a quick look at this video from IHS.
That's the Insurance Institute for Highway Safety's front crash of a 2009 Chevrolet Malibu and 1959 Chevrolet Bel Air. In slow motion, you can see the differences in how the new and classic cars perform in this version of the traditional frontal offset test. The Institute conducted this test to commemorate its 50th anniversary, and it dramatically shows how much improvement has been made in passenger protection since the nonprofit organization opened its doors. The two cars collide in an explosion of metal, glass, and plastics. Where the Malibu Crumple Zone absorbs much of the crash forces ahead of the windshield, the Bel Air structure allows the lighter car to compress the passenger compartment. The impact is made worse for the Bel Air driver by the lack of airbags, head restraint, and even a seat belt. As a result, injuries to the neck, chest, and both legs would be likely. Consequently, the Bel Air receives a poor rating across the board. On the other hand, the modern Malibu provides good protection, with the dummy movement being well controlled. Measures indicate a low risk to most body regions, though a foot injury would be possible. Beyond the safety gear, advancements in vehicle engineering give the Malibu a clear advantage in this matchup. While classic cars are often considered to be rock solid, this 59 demonstrates how much better today's cars are, and the IHS has played a key role in driving these advancements. In the past 50 years, the Institute has made a real impact. The roads today are safer for it.
So you've heard they don't build them like they used to, and it's true. And that is definitely for the better. You know, this picture here is from the movie Back to the Future, where they're flying over Biff's car in their DeLorean. You know, Marty, he's in a 46 Ford, we're in a DeLorean. He'd rip through us like we were tinfoil. You know, maybe not the case. So who has seen this rear seat airbag? So future regulations and ratings may put more focus on rear seat occupant safety. And as technicians, we need to be on the lookout for changes in the rear seat environment that could impact the way we install car seats. So one example of this is the possible addition of more airbags in the rear seat area. So in 2019, Car and Driver published an article indicating that Mercedes-Benz was developing a type of tubular airbag for the rear seat to deploy in frontal crashes. So not long after, the 2021 S-Class became the first vehicle with rear seat frontal airbags. So while this might seem downright alarming to us as technicians, it's important to keep in mind what we learned in our technician training, which is always go to the owner's manual to understand best practices, directions, and information on new technologies. So if we go to the owner's manual for the S-Class, we can see that the rear seat airbag can be disabled via the multimedia system, and it should be disabled for a rear-facing child seat. Mercedes is a little more flexible when it comes to forward-facing child seat, but again, the key point is by going to the owner's manual, we're able to see what the manufacturer says we should do regarding this new and emerging technology. So a couple wrap-up points for the section for CPSTs. Airbags are a beneficial safety feature designed to work with seatbelts to extend the time it takes for the occupant to come to a stop in a crash and spread the crash forces out over a larger area, reducing the chance for injury. Studies from NHTSA and Transport Canada have shown that seat side airbags and curtain airbags do not pose a significant risk to children properly restrained in child seats. So unless specifically otherwise instructed by the manufacturer, you may install a car seat in a location with the side airbag. And as technology evolves, watch for additional airbags or other technologies maybe we haven't even thought yet that are in the rear seat area, and be aware that they may affect the way you install a child seat. But always consult the vehicle owner's manual and the child seat owner's manual for guidance on emerging technology. And with that, I'm going to turn it over to Daniella to talk about crash dynamics in car seats.
Thank you so much, Jennifer. I miss being with Jennifer when we're doing this presentation because we tend to have a lot of fun. So, so bear with us. We are still counting on having fun. Anyways, when we talk about car seats and crash dynamics, the two terms that are used widely in the industry is payout versus ride down. And in an effort to address this and explain this properly, one thing you're going to notice in the next few slides is I'm going to be talking about payout, and payout is a stretch in the system, right? So we're stretching that system to the maximum amount. And ride down is the time it takes to stop after payout. So payout is after, ride down is after payout. We really ideally want more ride down and less payout. So I really like this visual because here you can see there's an adult. So you could, by looking at where the adult is placed on this timeline here, the ride down is going to be a lot larger than the payout. I'm obviously going to answer this, but just to pose the question, why do you think an adult has less payout and more ride down? Hopefully the answer came quickly to you just by looking at this visual here. The adult only has the vehicle belt that is restraining them. So they have the stretch of that vehicle belt when they're moving forward in a frontal impact. What happens with a CRS, a car seat child restraint system, whatever way you want to mention that or say or indicate it, is you have so your car seat's installed to the vehicle. the car seat will shift forward on impact toward point of impact. So you have the stretch in either the seatbelt system or the lower anchor system, if you have webbing attached to those, for example. And then you have the occupant that is in the car seat. So the occupant has to shift forward, and there's stretch that's going to happen in the internal harness. So that's why the two systems have a different amount of ride down. Ideally, we want to get that car seat restrained in the vehicle properly according to car seat manufacturers' instructions, so that we can utilize or have a larger ride down and utilize the safety features in the vehicle, much to what Jennifer was discussing, those safety features being airbags. There's also some other ones, but I know that what she just went through was heavily airbag based. Next, please. So this video is great because it talks about payout versus ride down. So go ahead, Jennifer. So I'm going to let it run through all the way. So what happens is you see the system, it's fully loaded, boom, and now everything starts pulling away from the seat. You saw the occupant go forward. So I'm going to have Jennifer run that again, and I'm going to have her stop at a certain point approximately, right about now. Okay, oop. That happens to me all the time when I do this, by the way. Go ahead. And right about now. Okay. So what's happening here, do you see how there's a little orange yellow frame that is pulling from the blue frame? At that point, we're having the energy absorption happen. So what's happening is the slack has stopped. So we no longer have slack. We're past, we don't have any energy absorption happening right here. But at this point, prior to this point, at this point, energy absorption is starting to happen. So if Jennifer presses play on this, so you see everything pulls out, and then it's designed to absorb and pull back in. Okay, we also see some energy absorption with the car seat rolling into the cushion, to the vehicle cushion. So next slide, please. So what is energy absorption? Sorry, that's just my husband leaving. What is energy absorption? So here we have two situations. We have a rubber ball and we have a memory foam ball. Kind of going back to what Jennifer was explaining as well. If we have the same applied force, so let's say we take the same arm and we are throwing the ball on the ground. They both have the same applied force. What's going to happen is, think about that. The rubber ball is going to bounce up, right? It has rebound. What happens with a memory foam ball is you might get a little bit of bounce, but not much, because it's designed to absorb energy. Again, same applied force down, one's designed to absorb energy, the other is not. Next slide, please. So there's a lot of things that that talk to us about, about this energy absorption. Sometimes, you see materials, and the materials are different. We have a rubber ball versus a memory foam ball. The design, the shape, the size, the structure, they all play a role in that energy absorption that happens. Britax has, in the back of their car seat, it's their forward-facing harness seat, they have honeycomb structure. That's strategically placed to absorb energy there based on how they're seeing the occupant reacting in a forward crash. And also the force, we have to consider the size of the force, where it's applied and how it is applied. So all of these play a role in energy absorption. Next slide, please. So the main thing I wanted to point out in this is going back to that timeline visual that I had a couple slides ago. The better coupling to the vehicle allows the car seat to gain better usage of the crumple zone. And Jennifer mentioned this too. So coupling to the vehicle. So in a car seat, we're talking about that install, having it installed correctly, tightly, according to instructions. The better we utilize that, the more effective we're going to be able to use all the safety features. In this case, we're talking about a crumple zone. There's that crumple zone in the front of the vehicle. It's designed to crumple and absorb there rather than transferring to the occupant. Or what it's doing is it's slowing it down so you have a longer ride down. Sorry, next slide. So seat belts and latch. Next slide, please. I'm going to hand it over to Jennifer.
So you guys are missing out. If we were in person, we would actually do physical high fives.
Oh, yeah.
Every time, which is a lot of times, and it doesn't get old. Well, at least it doesn't get old for us. So in your technician guide, you learn not to use the seatbelt and lower anchors at the same time to install a child restraint unless both the vehicle and child restraint manuals allow. But you might still be wondering, why wouldn't I be able to use both? Wouldn't more attachments be safer? So just like most people would not combine their contact lenses with their eyeglasses, we don't want to combine the lower anchors with the seatbelt. But why? So let's talk a little bit about FMVSS 225. So FMVSS 225 tests the strength of the latch system by using these metal test fixtures that take the place of car seats during the strength test. So we use these standardized fixtures so that it's not really feasible for us to test every single brand of car seat in our vehicles. Car seats change over time. So NHTSA has set these test fixtures as a replacement for our vehicle side testing. So we have two different types here. The SFAD2 on the left is used when we have lower anchors or lower anchors with the tether anchor. The SFAD1 is used with the vehicle seatbelt and the tether anchor. So when you look at this SFAD2, you can see that it has these rigid attachments that are spaced 11 inches apart and no place to route a seatbelt. The SFAD1 has a place to route a seatbelt, but no place to attach to the lower anchors. So this means that there is no NHTSA kind of defined way for us to test lower anchor strength while also using the vehicle seatbelt. So for a manufacturer to do this, we have to actually design our own tests and decide for ourselves how we would want to confirm the performance. So because there isn't actually a set way to do this, many manufacturers do not.
Okay. So, there comes a question, are they better together? With seatbelt, FMVSS 210 is the standard, the regulation that the vehicle manufacturers follow. And then we have FMVSS 225 for the lower anchors. Very simply put, the vehicle manufacturers, they don't test car seats. And then, well, actually in both cases, right? But then the car seat manufacturers, we're not testing the seat belts, and we are not testing we're not testing the latch either, and the strength in which they adhere and whatnot, and the fatigue. So vehicle manufacturers do not combine these two standards, neither do car seat manufacturers. So even more of a reason and a simpler way of putting it, why you don't put them together. So where did latch come from? So latch, as we're all familiar from curriculum, is the lower anchors and tethers for children. So it was developed in a way to obviously try and increase the usage of car seats installed correctly. And it came into into law back in September 2002. And we see that in our labels right now too. Next slide, please. So when we look at the history of the seatbelt, so it started, and I thought this was interesting once I started digging into it, and there's a lot more information in this timeline. So I just picked little points. So the first seatbelt was patented by a New York resident to keep tourists safe in taxis in 1885. 1922, it was designed by a parachute manufacturer for the race car industry. And then 1959, there was, it's actually this gentleman here on the right. This is Niels Bohlin, and he was a Swedish engineer that invented the first 3-point belt system. And it wasn't until 1968 where we were mandating seatbelts in vehicles nationwide. So when we're looking at seatbelts and latch, is one by itself really better? That poses the other question. So I think what's important is we have to go back to our roots in our curriculum, and we have to really look at the fact that the best method and location is one that works best for our car seat, our vehicle, and where you or your family, we can get that tightly installed every time. So these are just some factors to consider. And, there's obviously probably a lot more, but all of these things play a role in location and the method of install.
your buckle location, whether there's tall occupants, seat depth, belt path, vehicle instructions, car seat manufacturer instructions. I know it's a lot to know, but really just go back to our roots in our curriculum and make the best decision based on the method of install, the location, and the car seat and your vehicle.
So a little bit more history about seatbelts and lower anchors. So the lower anchors is part of the latch system. So that weight limit was decided by NHTSA based on the initial sled or dynamic testing that was done by Transport Canada in the late 1990s that then was used to develop BSS 225. So that specific testing used a 48-pound crash test dummy and a 17-pound car seat, which combined equals 65 pounds, which is probably a number that's going to be ringing a bell for all of us technicians and instructors here. So based on that development, NHTSA now limits latch use to 65 pounds combined weight, child and car seat. So the same as the initial crash tests that were used to develop the strength of the lower anchors. So we have that 65-pound limit for latch. When we look at the vehicle seatbelt, though, those are designed to restrain an adult occupant. So to put that in context, the adult 50 percentile male crash test dummy weighs 171.3 pounds. So if you have a parent that's concerned about using the vehicle seatbelt, they feel they should be using the lower anchors because maybe they feel the lower anchors are safer. This is one little tidbit that you can use. Latch, 65-pound weight limit, crash test dummy, 171 pounds. And again, so when we're under 65 pounds, you can use, of course, either the lower anchors or the vehicle seatbelt, whichever one is best for your situation. But when over 65 pounds, that's why we use the vehicle belt. So next, let's talk a little bit more about latch. Let's talk about lower anchors and center borrowing. So you may be wondering, why don't all vehicle manufacturers just allow latch center borrowing? Make all of our lives easier when we have that new parent that rolls into the check station with their rear-facing car seat installed in the center seat, using one lower anchor from each of the outboard seats. Wouldn't it be easier if they could just leave it like that? Well, here's why. So back to our good friend BSS 225. It specifies a lot of things. It says the lower anchors have to be located in a seat bight, which is where the seat cushion and seat back meet. They can't be stowable or removable. They have to be made out of a 6mm wire. They have to be between 25 and 60 millimeters in width. They have to be spaced 11 inches apart. They have to be rearward of a certain reference point, but more forward of a certain reference point. They have to be labeled with 13mm diameter symbol if they're not.
Jennifer.
Yep.
So we are dealing with some pretty rough echo. Do you happen to have anything to do with that? We're trying to make sure we can get it so people can understand the information you're trying to put out there.
It might be because someone else isn't muted. They might have two devices going at the same time.
Okay.
So maybe everyone can mute their device, please.
Well, everybody besides the panelists should automatically be muted. They're not able to.
Yeah, I was just double checking that all the participants are muted.
I can try to mute and unmute myself, but
I can say when you started off on this webinar, your audio was fine. So if anything changed between the beginning and this last time.
Nothing has changed. Is that any better?
Keep talking.
Testing, 1, 2, 3.
No, you're still have quite a bit of echo there.
Shoot. Yeah, my settings have changed. I can drop and rejoin. Give me 1 minute.
While Jennifer's dropping and rejoining, does anyone have any questions about the presentation thus far?
There are some in the Q&A if you're looking to go ahead and take care of some of those at this point.
Sure.
All right, so we'll go in order here. It says, we are seeing more vehicles with front center airbags. Is there concern with this airbag interacting with a rear-facing child restraint installed in a rear center position that nests between the two front seats.
All right, is that any better?
Much better.
Yay.
All
Jennifer,
right,
did you hear that question?
I did not.
How about we come back to it,
We can
Justin?
come back to
Okay.
this. Absolutely.
Great.
Jess, if you can re-enable screen share so I can get the presentation back up.
You got it.
We will overcome the technology challenges today. All right, can you see the screen?
We can see it and you're coming in clear.
Fantastic. All right, since you guys probably couldn't hear me very well, I'll recap this a little bit. So our good friend FMVSS 225 mandates a few things. It tells us the lower anchors have to be in the seat bight. That's that gap between the cushion and the seat back. They can't be stowable or removable. They have to be made of a 6mm wire. They have to be between 25 and 60 millimeters in width. They have to be spaced 11 inches apart. They have to be at least 120 millimeters rearward of a certain reference point, but also less than 70 millimeters rearward of another reference point. And they have to be labeled if they're not visible. So back to these test fixtures that we looked at earlier. So again, we have these rigid attachments on the SFED2, which is the only fixture that will attach to those lower anchors. So if we want to test the spacing that's not 11 inches apart, we don't really have an option here. So essentially we have to use this SFAD1 on the right and modify that with a flexible attachment fitted with latch. So again, that means that there is no NHTSA approved test to test the strength of the lower anchors when we have a spacing that's different than that 11 inches apart. So if manufacturers want to allow center borrowing, they have to decide themselves if and how to confirm the strength of those lower anchors. Because again, no standard test for those lower anchors greater than 11 inches apart. So, okay, I understand that, but we said, hey, they've got to be a 6mm wire. They have to meet these certain sizes. Why can't I just assume that it's safe to borrow anchors for center latch installation? Don't all those lower anchors have the same strength? Well, that's a great question. So again, they have to all be that 6mm wire, but the attachment method, to the vehicle seat or to the floor, as well as the strength characteristics in those areas, that might vary from anchor to anchor, even though they might all look the same from where we can see them through the seat. So, our lower anchors work in teams of 2. So just like with people, not all lower anchored team members have exactly the same characteristics. So this might be because of asymmetry in the vehicle, packaging constraints, reinforcement placement, or other reasons. So let's consider a hypothetical situation. So we have these anchors here that I've labeled 1, 2, 3, and 4. So let's imagine that for whatever reason, lower anchors 2 and 3, the white ones, have a different strength characteristic. So when we have our standard spacing, 1 and 2 are a team, so 1 blue, 1 white, and 3 and 4 are a team. So in a front impact, these teams will be loaded in a forward direction, like you see in the arrows here. But if 2 and 3 are a team, so we have those 2 white circles, so not only is it possible that as a team, they might have different strength characteristics than those standard blue and white teams, but in a frontal impact, they're loaded on an angle, which changes the loading condition. So this really means that only the manufacturer who knows all of the details of the design and the performance can confirm if center borrowing is actually allowable for any given vehicle. So while we're on the topic of latch, let's talk about pickup truck tethering. Who gets excited when they see a pickup truck roll into their check station? I'm sure there would be lots of hands going up if we were in person, right? So why are the tether anchors in pickup trucks located in so many different places? And why aren't they just behind the head restraints like they are in sedans? Wouldn't that just be easier? So again, our good friend FMVSS 225, it tells us where the tether anchors are allowed to be in the vehicle. So in 225, it tells us this hook shape that you see on the tether is standardized, but the vehicle anchor shape is not. Tether anchor labeling is not required. And the tether anchor zone is large, but it has prohibited areas near the head restraint. So this gray area is everywhere behind the seat that the tether anchor can be. except you can see this white cutout right kind of behind where the head restraint would be. So if we think about a pickup truck, why is it so varied? Well, location, 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 just like real estate. So you can see in the image here on the bottom right, we have that same zone that I showed on the previous slide, but that red dotted line is kind of a rough indicator of where that back wall behind the seat in a pickup truck would be. So as you can see, the area that would be like behind the headrest is actually in that white prohibited zone. So what that means is we can't actually put the tether anchor there. So if the customer can access the area behind the seat back, like say the seat tips forward, the vehicle manufacturer has to put the tether anchor somewhere in that gray zone. If the customer can't access behind the seat and can't access the other parts of the zone, then the vehicle manufacturer can use a tether rerouter and locate it somewhere else on the vehicle. And with that, it's back to Daniella.
All right. Thanks, Jennifer. So I know I get asked this a lot by parents. Why do we check harness tightness at the shoulders, right? Next slide, please. So I think at one point, there we go. All right. So at one point it used to be checking with 2 fingers underneath. However, I don't know if everyone else has noticed this, but everyone's fingers are different, and evaluating this tightness can be, different as well. So that was in the past. And now we really do this evaluation doing the pinch test at the shoulders. Next slide, please. So why do we do it here? So the harness contacts the body before and during a crash at the shoulders. So here we have rear facing seat. So child in a rear facing convertible. And the one on the left is your starting position. Okay. And with everything moving toward point of impact, what's going to happen in the photo on the right is you'll see the rotation that starts happening toward point of impact. As the car seat is rotating toward point of impact, the child is shifting upward, which is why we get some stretch in the harness system as well. But if we were to zoom in on that area, guess where it's touching the child's body? It's happening, and it's happening, contact is happening right there on top of the shoulders. So that's the first one. So for rear facing. Now with the next slide, we talk about forward facing. So once again, everything moves toward point of impact as seen in the photo on the left. The photo in the middle, this is when that full movement has occurred. So the stretch that happens in the seatbelt system. Zooming in on that area, if we pull that out to the right, look where contact is happening. It's happening on top of the shoulders. Next slide, please. So that's why we check on the shoulders, where we're saying, look, check me here, check me on top of the shoulders. One thing that I have noticed is I have a lot of parents that they want to check right at the torso, right? They're wondering how come there's such a gap. So after you buckle and you pull up on the harness to get rid of the slack in the hips, you're pulling and tightening in front on the adjuster and then doing that chest clip. More than likely, you're going to have space at the torso. The reason why I bring this comparison up is because contact is happening at the shoulders. That's where we do the pinch test. The chest clip helps position it. The space we see between the torso and the harness is normal. What drives that is the torso width, as well as where the buckle is positioned relative to the child's pubic bone. So again, contact is happening here and during a crash. This is where we're checking. So there's our why behind why we check at the shoulders. Next slide, please. So keeping in line with talking about harnesses, why do we have chest clips in the United States? Next slide. So what is its purpose? So I'm sure everyone, a lot of people know, but just in case, the chest clip is a pre-crash positioner. So what it does is it holds the harness in place on the child's shoulders right here. It's the harness itself that is keeping the child contained in the car seat. So the harness should be tight, which we talked about doing the pinch test on the shoulder. That's how we check tightness, right? We don't want to gather it. And it properly positions the straps over the child's shoulders there. Next slide, please. So not sure if you know, but chest clips are not required here in the United States, and they aren't visible in many cases over in Europe. So in the US, it is not part of our regulation to have a chest clip or retainer clip on our car seats. It's not necessary for crash protection because we talked about how the harness is what is keeping the child inside. However, it's on all car seats, so it's almost expected. So again, what it's doing, it's a pre-crash positioner, and it's properly positioning the harness over the shoulders on a child. So in Europe, there is an R44 regulation, and it requires a child, part of their requirement is this child must be removed from the car seat with one single hand release. So having a chest clip plus a crotch buckle, that would mean there's two motions that have to happen for a child to be released from a car seat. The chest clip is also close to the neck, and this is their viewpoint. So in group 1, which is their forward facing, and groups 0, 0 plus, and 1, which are rear facing, the neck of the child can touch the chest clip. So this is another reason for why they don't have them as part of the R44 regulation. However, R129 over in Europe is replacing the R44 regulation. A shoulder strap positioner is permitted. Again, not required, it's permitted. So it's possible to release the child from the restraint by a single operation on a single buckle release after the release of a shoulder strap positioner, which is what they're calling the chest clip. So there are some stipulations on the size, the force, and the function of the chest clip. But I just thought that was interesting, that I think we've always known it that over in Europe, they don't have chest clips. And over here, it's not regulated, but we understand the necessity and also the benefit of having it. Next slide, please. However, like I mentioned, in R129, there are chest clips in Europe. You can actually buy this as an aftermarket product and put it on your car seat. So next slide, please. So keeping in line with discussion on the 3-point harness and 5-point harness, what is the difference between the two, and is one better? 3-point harness. We see this over in Europe quite a bit, and it's historically, was first seen on the Maxi Cozy, this harness system. So as you can see, I've pointed out the 1, 2, 3, which makes up the 3 points of contact there. It's easy. It's said to be easier to use and creates less slack in the hips. So because you don't have your point 4 and 5 in your hip points, you don't have to worry about lifting up and removing slack on a 5-point harness like you would on a 3-point harness. It can require a higher force to use that CFA, which is the central front adjuster. That is the mechanism when you pull the harness to tighten. That's the mechanism in there. In the European Consumer Reports group called Stiftung Warntest, they evaluated the two harness systems, the 3-point and the 5-point, and they were rated actually very similar, with the 3-point being slightly better than the 5-point harness system. Next slide, please. So in a 5-point harness system, it's actually not required per regulation. It says that we just need a combination pelvic and upper torso restraint system in the car seat itself. What happens with the 5-point harness, in here I've indicated the 1, 2, 3, 4. It restricts movement and properly restrains during all kinds of crashes. And I've listed what those are: frontal, rear, oblique, rollover, just to name a few. The curriculum, we talk about how that 5-point harness helps distribute the crash forces over a large area of the body, and why that's just so critical. And it comes down to those 5-point attachment points. They were designed to restrain at the hard points of the body. So the shoulders, the hips, and also the more rigid parts structurally on an occupant or a child in this case. Next slide, please. So which one is better? Is it the 3-point harness or the 5-point harness? To be honest, they are both good systems to restrain a child. Different countries, different viewpoints on this matter. Next slide, please.
All right, so now let's talk about rear-facing child restraints and vehicle seatbacks. So you learn in curriculum to check the vehicle and child restraint owner's manuals to learn if the child restraint can touch the vehicle seatback when installed. But you might be wondering, how do manufacturers decide this, and why does it vary from manufacturer to manufacturer? So on the vehicle side, under FMVSS 208, vehicle manufacturers have to classify occupants sitting in front seats to determine if, when, and how powerfully to fire the front airbags in a crash. So this means they have to decide, is it maybe a 6-year-old child in a car seat? Is it a small female? Is it a 50th percentile male? So the methods to do this vary by manufacturer. So some technologies that are used are affected by the presence of a child restraint pushing against the back of the vehicle seat, but others are not. But regardless of the technology type, the driver should always sit in a comfortable position to safely operate the vehicle. They're more likely to get into a crash if they're not properly and comfortably seated. So some examples of sensor types are pressure mats, seat slide position sensors, weight sensors, capacitance sensors, optical camera or sensors, or radar sensors. So a weight-based sensor, for example, has different points on the seat track that are used to calculate the weight of the occupant. So you can imagine if you had a force pushing on the seat back, like a rear-facing car seat, it might interfere with that weight calculation and cause the vehicle to incorrectly determine who is sitting in that seat. So that's why you always need to check the vehicle owner's manual to make sure whether or not it's okay for there to be contact there. Let's talk a little bit about vehicle head restraints. So you know that you need to check the vehicle owner's manual for instructions on positioning the head restraint, but you might be wondering, why do the instructions vary from vehicle to vehicle or manufacturer to manufacturer? What if the owner's manual doesn't mention head restraint position? Or what if the head restraints interfere with the child restraint, but they can't be removed? So why do the instructions vary? So each vehicle seating environment is unique, and manufacturers have a whole lot of factors that they have to consider. For example, the tether anchor location might influence whether the instructions say to raise, lower, or remove the head restraint. So whether the tether anchor is on the vehicle roof, whether it's on the seat back, those are considerations. Narrow seats may have different instructions than wider seats to make sure the tether strap doesn't slip off the seat back, especially for a V-shaped tether. But what if the owner's manual doesn't specifically state how to position the head restraint? Well, in that case, we want to make sure that we don't violate what is stated in the owner's manual and contact the vehicle manufacturer if you have any additional questions. But what if the head restraint interferes with the child restraint, but they can't be removed? Well, the first thing you can do is try placing the child restraint in another seating position. So the seat geometry might be different and allow for a better fit. This is especially true between like a center seat and an outboard seat. You can see in this vehicle here, the two headrests you can see have pretty different profiles, so you might get a different fit. And you can also check the car seat owner's manual. So some child restraint manufacturers permit installation with a gap between the child restraint and the seat back, as long as there's still a tight installation, so that less than 1 inch of movement side to side and front to back, and no part of the child restraint is pushed out of its normal position. So again, you need to go back and check with the car seat manufacturer for that type of situation. And now back to Daniella.
Thanks, Jennifer. So side impact pods, what happens if we don't use them? Oh, sorry, you have to move it. All right, so you can run this video right here, Jennifer. Great. So this video is public information. This is a seat that has head containment. And I guess the reason why I wanted to show this is just explaining what happens with the occupant in a side impact collision. So you get a really good view on the top view, what happens with the head. The head will pull out a little and then roll toward point of impact, which is where those big headrest ears come into play in properly protecting a child in a side impact collision. I'm just going to continue to let this run. You'll notice red as well, little chalk flying a bit. And that's to see where contact happens. So it transfers from the occupant to the device it hits, so they know that contact happened there. And you'll see this a lot in testing. Okay, next slide, please. So the way I look at it as is there's a lot of different side impact features in car seats. In some cases, we have pods. In some cases, we have devices that have to be pulled out. And the point of them is they are supposed to gain that point of impact first rather than transferring to the child. this kind of also goes back to our discussion about energy absorption. So take a pop can, for example, right? It starts out, and imagine it's horizontal on a seat, okay? And your point of impact happens here. So this is stable, well, you know, as much as possible, right? So what happens is your point of impact happens, and then it starts crushing and absorbing. And as it's crushing into, and we know it can get as lower than the third one on the right, but as it's crushing to that minimal point, that minimal crush point, I guess, that's where all that energy absorption has happened. The big thing with this is to follow the car seat manufacturer's instructions for use. Encourage the use, in other words. This is an added safety feature that's on car seats, and it's similar to a Crumple Zone technology. It absorbs those crash forces and it disperses those forces away from the occupant. Next slide, please. So these are Cybex products. This is their LSP, which is a linear side impact protection. On what you can see on the left with the gray is when it's in is how it's shipped. And then the one on the bottom would be, you'd have to push it to have it pull out. So in this case, it is part of their installation process. So if it's part of their installation process, then that's telling me I should be using it as a technician. Same thing, and what the one on the right is showing is just, you know, on the door side, you have to expand or flip this out to activate it. And just by using it, you can reduce near side impact forces by up to 25% when used. So once again, you know, they're telling me to use it, I'm going to use it. Moving forward, Cybex is actually having these already shipped, already extended too, which is nice. So we're less dependent on the occupant, or not the occupant rather, but the end consumer to pull that out and use it. Next slide, please. So these side impact pods, same thing with Nuna. Nuna has a same device similar to the LSP on the Cybex. So they call it their side impact protection. And this is pulled directly from their manual. They're asking you to pull out the side impact pod from the corner. And that's the way it extends, as in number 2. You can kind of see it. It's hard to see it on a side view, but it is extended in this blow up view of the Nuna Rava here. So they are also part of their installation process as well. And the new model Nuna products, you say that 5 times fast, do not require the pods to be activated. Next slide, please. So the UPPAbaby products have the same thing. These pods are on our Knox, which is our convertible seat, and the Alta. This has a cone-like feature inside. So they are activated at all times. So they're just out there. And if you look at them from a pure front view, you'll see them. They are proud of the seat on the side. So it is a special foam in there, and it's a cone-like feature. So here we go down to the materials and the shape of the materials. Those are designed to absorb there rather than transferring those forces to the child. Next slide, please. So this is all we have, Jennifer and I. We were able to move through this rather quickly, which is nice because we can field some questions and answer and just have some open discussions about a few things. So I'm going to turn it over to Justin if you'd like to take the reins.
Definitely. We have some questions for you guys, and thank you for all that information. It's a lot to take in. I know I'm going to have to go back and watch the recording once it's posted so I can try to, make sure all of it soaks in for myself. So we will go in chronological order here. And certainly whichever one of you feels like you are best suited to handle the question, we'll let you unmute and answer, starting with, we are seeing more vehicles with front center airbags. Is there concern with this airbag interacting with a rear-facing child restraint installed in a rear center position that nests in between the 2 front seats?
So we mean the center airbag, the center side airbag for the front seats, yeah. So I think, again, Toyota doesn't have any vehicles currently with that front center airbag, so I'm not an expert on their interaction with child restraints. But again, just like any technology, I think going back to the vehicle owner's manual will alert us if there is a concern for that type of interaction. But unfortunately, I can't give you the Toyota perspective since that's not our technology.
Okay. Next question. Isn't a rear airbag still at risk of deploying when it is disabled?
Oh man, you guys are throwing out the tough ones today. So we do only have one rear seat airbag at the moment, and that is the Mercedes airbag that we talked about earlier in the presentation. It's probably a better question for them for their actual technology. You know, the disabling, right, is turned off via a user-defined interface rather than just a sensor system. So I imagine they are fairly confident in that disabled technology. But it is a little bit different than kind of the old kind of key turn style that is maybe more of a physical disconnect.
Have any CPSTs worked with caregivers to install car seats in the rear seat with a rear seat frontal airbag? Wondering how well Mercedes labels the airbag so that they know that there is one.
So I do know that there is on the airbag, I've seen a photo of it. I have not seen it in person. And Jennifer, I don't know if you're in the same boat as I am. There is a molded in airbag sign, you know, how we see the markings in vehicles, and we saw it in, you know, when we were going through a curriculum. There is a molded in sign right there that would be in front of the back of the vehicle, and it's plastic. It's this big plastic panel. Otherwise, I am not sure if there's a technician that has physically run into having to disable it. This vehicle is a pretty high-end vehicle too, to my knowledge. So I don't know if Jennifer, you've anything to add?
No, I've only seen pictures like you have. So as you said, there is a label there, and it is just the one vehicle, very high-end, pretty low volume. So I don't think it's something technicians will be seeing kind of regularly in the field. But again, rather than focusing on that specific technology, I think the key message is really, you know, autonomous vehicles are coming. We've seen all these images of living room style seating in vehicles for forthcoming AVs. And, you know, with all of these major changes in the industry, we will see changes in rear seat restraints. We don't know what all they will be yet. So as technicians, the main takeaway point is to keep going back to those manuals and learning about the new technology as it emerges. It's a time of change. It's going to change, and we have to learn how to roll with it and change with the times.
All right, next up. When the car seat check form asks if there are airbags near the child or the restraint, are you supposed to record yes for side curtain airbags?
I would say yes, that is an airbag near the child. It doesn't mean that it's an incompatibility, but there is one located near the child.
Mm-hmm. I agree, yes. Not that it matters what I say, but.
Oh, come on. How do crash forces work in a rear end crash for a rear facing car seat? I see it asked in the Facebook groups and never really understand how to answer that question.
Great question. So as we all know, when we talk a lot about frontal crashes, because that's what the 213 is based on as well. And statistically, that's the highest crash that occurs. Statistically, the rearward crash is said to be the second highest based on data that I saw, and I saw that a couple years ago, so that might be different now. But what happens in a rear crash is the same thing. So everything would move toward point of impact. You see a lot of, so it'll rotate into the vehicle seat back. So we do see a lot of technology in seats right now. I know we have a seat that's coming up that has an anti-rebound panel. We call it an anti-rebound plus panel because when we talk about anti-rebound, we're referring to in a frontal crash. So in a frontal crash, right, you're going to rotate forward and then it's going to rebound into the vehicle seat back. Our panel, we call our anti-rebound plus panel because it also is utilized and works in a rear impact. So in a rear impact, it's going to rotate toward the back vehicle seat back first. So that panel is there to absorb those crash forces. So there are a lot of products out on the market right now. I know Britex has an anti-rebound bar, as does Kleck, and I know I think Nuna just came out with one. There's quite a few that are out there. Those features are also great for a rear impact crash. Hopefully that answers the question.
If I can add on to it a little bit
Yeah.
too. So I'm reminded of a conversation I had with a caregiver. So he was turning his daughter forward facing, and his reasoning was, well, isn't the dynamics basically the same if it's a rear impact that gets hit, or rear facing car seat with a rear impact? Isn't that the same as a forward facing car seat in a front impact? And I know that I'm a good driver, so I'm not going to get into a front impact. I'm worried about the person behind me who's going to rear end me. I was like, this is a really great conversation. All right, so let's talk about this. So that forward-facing car seat in a front crash, we've seen a lot of videos, and we can see the kinematics of the dummy in the videos kind of going forward, Superman style, right? So really pulling away from that harness. We see the legs, we see the arms, we see the head going forward, and all of that tension on the head and neck. When you see a rear-facing car seat in a rear impact crash, right, we have that reclined seat that rotates, the whole seat rotates forward as a unit. So we don't get that same kind of Superman effect of the occupant. The occupant and the seat kind of move together. So even though we are rotating towards that primary direction of impact, the kinematics of the occupant are a lot different. And so a forward-facing car seat in a front crash is really not equivalent to a rear-facing occupant in a rear crash. So with all of those things combined, that's why we still say it is safer for the occupant to be rear-facing as long as possible, because those two things are really very different. And anecdotally, that same parent shortly afterwards was involved in a front crash. So, take it for what it's worth. His daughter was fine.
Next question has to do with seatbelt overlap in the rear seat. Why do some manufacturers design vehicles that have significant seatbelt overlap in the rear seat when the overlap prevents the simultaneous use of all seatbelts in the back? People think they can put 3 passengers in the rear because there are 3 seatbelts, but don't know that the overlap affects the effectiveness or even usability of the seatbelts.
That's a great question. So I wouldn't say that seatbelt overlap prevents 3 occupants from being in the rear of the seat. You really need to look to the owner's manual. For example, you might just see a warning about making sure that everyone's seatbelts fit properly due to the overlap. So if the seatbelt is there, it generally is okay to be used. As to why they may overlap, there's various regulations and ratings that manufacturers have to meet. You'll see that most often in smaller, narrower cars, right? Well, that's because there's less space to work with. So it's a balancing act, just like a lot of things in vehicle safety. We're trying to make sure that we keep the seatbelts as separate as possible, but at the same time, if the seatbelt anchors are too close together and we can't get a person in there, then it's not a great condition either. So it's all this balancing act. We need to just make sure the seatbelts are fitting properly, whether we have belted occupants, whether we have car seats back there. Proper fit is key.
Why is it required in Europe that the child must be able to be removed from the seat in a single hand release?
I wish I could respond to that, but I didn't write the regulation. If you want to shoot me an email, I could probably do some more digging. I'm sure that there were studies behind how they came up with the regulation. I'm assuming it's just to be able to exit the vehicle quicker, get the occupant out quicker. But please feel free to email me. You can email me at carseat@UPPAbaby.com or Daniella with 2 L's at UPPAbaby.com, and I will do some digging for you.
All right, since latch on a booster is only designed to hold the booster when unoccupied, would it be detrimental to borrow center latch for a booster if the vehicle doesn't allow center latch? assuming the seatbelt geometry is correct with the seat latched.
Okay, so using latch in a center seat on a booster where it's not the primary. Still, I would say follow the vehicle owner's manual instructions, even though the latch is not the primary load path in a crash. Still, we don't want to violate anything that the car seat or vehicle manufacturers tell us.
One thing to point out too, I know in the industry, we talk about using the lower anchors as a way of preventing the car seat from being a projectile, but it also puts the child in that pre-crash position. I don't know if you've ever looked in your rear view mirror taking a turn and you see, you know how everyone rolls, right? So will the car seat and the child. So honestly, that helps too, keeping everything in position as well. But just wanted to throw that little bit of information in there.
And our last question that we've got here in the Q&A, I thought we phased out 3-point harness seats in the US because 5-point harnesses were safer.
Well, I think that's our mentality. Over in Europe, it's not their mentality. We believe that, you know, it spreads those crash forces over the body a lot better. They have concerns with customer use and getting rid of the slack in the hips. As I mentioned, one of the things that's important to do when you're buckling a child in after you buckle. So it's just a different mentality. We believe it's safer over here in the US. We believe a chest clip is safer over here in the US. They have different opinions over in Europe.
Thank you. And there was somebody adding in a note for us that for the Mercedes seat frontal airbag, another participant said that it states the SRS on that.
Okay.
Okay. Well, thank you very much, everyone who joined us today. Reminder, this webinar recording will be posted to cpsboard.org/recertification within 1 to 2 business days. And for the child passenger safety technicians in attendance, the presentation qualifies for 1.5 CEUs. In order to earn the CEUs, attendance on this webinar is required for at least 75 minutes, and proof of attendance will be emailed 24 hours after the webinar. Thank you so much for joining us today. Have a safe day and a happy National Child Passenger Safety Week. We celebrate with you and thank you for all of your life-saving education you provide to your community. Go ahead and stop the recording at that point.